In this video, we'll do carbocation rearrangement, but in ring expansion. As you can tell, the positive charge is currently not on the most substituted carbon, so we need to put it on a more substituted carbon, but because that position is in a ring, there will be a ring expansion. So step one is to number all the carbons, starting preferably the one that is farther from the carbocation and ending on the one that is on the carbocation. So we will be drawing a hexane, but you have two options. You can use carbon 4 and connect it to 6, or you can use carbon 1 and connect it to 6. And in this case, I'm going to do carbon 1 connected to 6 because we kind of want the 5 bended here because of this methyl. So I'm going to redraw it. Then I'm going to number all of it again to figure out where carbon 5 is there, and we keep a methyl there. And this is carbon 6. Okay, and the other side is just going to remain the same thing. It's going to, actually no, it's not going to remain the same. It's going to lose 1 carbon. Okay, there's 7 carbons in this ring. Now it's only going to have 6 carbons, so we'll draw a fun cyclohexane here. Okay. Okay, now we want to find out where the new carbocation is. Okay, so hint, it's usually somewhere near the methyl, but so 5 used to have 4 bonds. Now it only has 3 bonds, so it's actually just going to be on carbon 5. To check, carbon 6 has 6 bonds, and here it had 2 bonds. That means it gained 1, so there's no need to put a carbocation there, and the rest of the things remain the same, so that's good. That means if you put this through an E1 elimination, so to draw it prettier, it's going to look like this. It's carbon 5 methyl, and our carbocation is here. So then if you do the E1 elimination, your alkene will just end up here. Okay, next problem. Number our carbons starting from the one farthest from the plus sign, and we can choose to connect 1 to 5. Yes, okay, let's do that. So now it's gonna have, okay, we still want carbon 4, so we're gonna add a little bend here to illustrate that carbon 4 exists. Okay, and then this is carbon 1, 2, 3, 4 with a methyl, 5. So what we did was we connected this together. 5 has a methyl on it as well. So who has a carbocation? 4 used to have 4 bonds, now it only has 3, so carbon 4 now has the plus sign. That means if we do an elimination, this is carbon 4, this is carbon 5. If we do an elimination, the alkene will be just right here. Last problem. First number our carbons starting from the one away from the carbocation and ending on it. So now we want to connect, we could choose to connect 1 to 6 will probably be the better choice because 5 already has a methyl here and we don't want to complicate things. So we'll draw a funny looking cyclohexane, number it. So carbon 5 still has a methyl, carbon 6 has 1 methyl, and who has a carbocation? So carbon 6 used to have 2, now it has 3, so good, no need to add a plus there. But carbon 5 used to have 4, but now it only has 3, so it's going to be on carbon 5. And if we put this through an elimination reaction, so we can tell that this is a cyclohexane. Carbon 6 has a methyl, carbon 5 has a methyl, carbon 5 has this plus, so if we do the elimination, the alkene will be right here.